Hi, my name is Josh Taylor, Master Service Technician with RapidView. Today at RapidView U, we'll be showing you how to reterminate a mainline cable. You want to start out by getting the right tools together for your retermination. You'll need a 15mm wrench, a 19mm wrench, a 2.5mm ball socket screwdriver, a small flat blade screwdriver, cable cutters, needle nose pliers, wire strippers, wire cutters, a razor knife, solder, solder wick, a hammer and punch, Molykote 111, a storage bin for your parts, alcohol wipes to clean off your parts. You'll also need a retermination kit provided by RapidView. Once you have your tools together, now it's time to think about safety. Anytime you're going to be working with a cable that's been in the field, it's a good idea to clean and disinfect the cable and the cable connector components that you'll be working with. Gloves are also recommended while doing a retermination, although I won't be wearing them for this demonstration. The first and one of the very most important things that you need to do when reterminating a mainline cable is finding and removing the damaged section of your cable. There's several areas in your cable that may have very small nicks in them. This is not a problem as long as the cut or damage doesn't go into the Kevlar portion of the cable. Here I've stripped away a little bit of cable so you can see how this is made up. It has an outer cable jacket. Now this cable jacket can be damaged so long as it's not cut all the way through. And underneath there's a fibrous Kevlar braid that gives the cable its pulling strength. If this Kevlar braid is exposed to the outside at all, this is a damaged area of the cable and it needs to be removed during your retermination. This type of damage that you see here, this is very typical if you've run into a line and got your cable cut on something sharp, and it'll slice along the length of your cable. So once again, the Kevlar is exposed. This needs to be removed before you do a retermination. There's another example of a very badly damaged section of cable. You have wires exposed, Kevlar's exposed. This is very typical of what you see if a pipe has collapsed on your equipment and you were unable to remove it. This type of damage is very likely for being able to damage your equipment further than just needing a retermination. If any of these copper wires cross one another, it's likely that you'll damage the electronics inside your equipment. This is probably the most common type of cable damage that I see. This is small little cuts where the cable has typically not been used on a downhole roller and used what's called a tiger tail to make the bend into the pipe. The tiger tail slips out of the hole and then this cable rubs along the rough edges of the pipe. And as it's getting pulled into or out of the pipe, this type of damage occurs. And it doesn't seem like very much, but what happens is water gets inside and it will corrode your video lines inside of your cable. There's just another example of cable damage. Once again, anything that exposes the Kevlar braid underneath needs to be removed before you do a retermination. Now that I've found my cable damage and cut away the bad portion of the cable, I'm going to take apart my cable connector. So this is pretty typical of what you see. I'm going to cut off all of this tape, heat shrink, vulcanizing tape, and Perlon wire.
When cutting off the heat shrink, or in this case the tape, it's important to note that you do not cut the cable boot. Cutting into the cable boot will diminish the watertight seal that it helps create. It's also important to note that this extra tape is unnecessary and potentially harmful because it can give the cable rigidity where the tape is present and a weak point directly behind where the tape is not present.
Okay, now I have all of the exterior protections. I have all the exterior protections off of this cable. So first thing I'm going to take off is my cable boot. So set that aside. There's a little bit more Perlon wire underneath here. Okay, as you notice, there's 4 screws down here at the bottom of my cable housing. So I'm going to take these screws off. Once you have the 4 screws taken off, the cable housing just slides back over the cable entry. Next thing you're going to notice is you have 4 additional screws here on your 1/2 connector holders. Now that we've taken off the 4 screws of our 1/2 connector holders, the next thing you have to do is your 2.5mm ball socket and take out these Allen head screws inside. Once you get your 4 Allen head screws out, one half of this connector holder should just fall right out, while the other half is going to be connected by the ground screw. So take this ground screw out, and then the other half will come off as well. Save your ground lug. Your socket insert should pull right out of the front half of your connector holder.
Now you can go ahead and cut the wires and finish the disassembly.
You have your socket insert alignment, your socket insert itself, and your cable entry. This is also the front of your connector holder. I'm going to take my front connector housing and pull all the O-rings out of it. When you purchase a return kit, it comes with all new O-rings, so there's no reason not to change them. Additionally, I'll take the O-ring off of my cable entry.
When removing O-rings, never use a screwdriver. We're using a brass O-ring removal tool. If you don't have one, a simple plastic crochet needle will do the trick. If you use a screwdriver, there's a good chance you'll damage the metal on the connector and diminish the watertight seal.
Any remaining cable that you have coming out of your cable entry, go ahead and cut that off. Use a 19mm spanner style wrench and a 15mm wrench, and you can take off your thrust ring. Once the thrust ring is removed, the thrust washer comes out. Pull the remaining wires out one at a time until they all come out. The cone is next. Use a hammer and a punch to punch the cone out of the cable entry. Remove any electrical tape or Kevlar from the cone. Now I'm going to clean up all the parts I've taken apart. It's important that you clean up all these parts because when this metal works clean and you put the new O-rings on, it makes a good seal. And keeping these clean and having a good O-ring seal is what keeps the cable's watertight integrity. So you don't want any water infiltrating into your cable and then forcing you to do another return prematurely. You want to make sure to clean out all these O-ring tracks to make sure that you have a good solid O-ring seal and make sure that you're not going to get any water infiltration into your cable. If you have any corrosion inside your connector, make sure you try to clean all that out as much as possible. Now that we've disassembled our cable connector, we can go back to the now good portion of our cable after all the damage has been removed and start putting the items back on in the correct order so we can reassemble our cable end. The first thing to go on the cable is this PVC tube from the Retermination kit. The next thing that's going to go on your cable is this smaller piece of heat shrink that comes in your Retermination kit. The next thing to go on the cable is the cable boot. The skinny end is going to go towards the drum end of your cable. The large end is going to go towards the cable end side. Push your cable boot over the top of your PVC tube. The next thing to go on is our connector housing. The 4 screw holes are going to go towards the drum end of your cable. Next in line is the cable entry. The next thing I'm going to do is strip back approximately 15 centimeters of the end of my cable jacket. When you're stripping back your cable jacket, be sure not to damage any of the Kevlar underneath. Now that we have our cable jacket stripped back, the next step is to put on our cone. The cone goes over the top of all this Kevlar, after which the Kevlar is going to go over the top of all the cone. So this braided Kevlar, when it goes over the top of this cone, acts a lot like a Chinese finger trap, and it gives the cable its pulling strength.
When pushing the cone down over the cable jacket, be careful not to damage the wires underneath the Kevlar with your pliers. An alternative method is to push the cone down with your hands.
You want the top of the cone to be even with the top of your cable jacket. The next step is to take this braided Kevlar, and if you just loosely pull it back, it should fit over the top of your cone. Inside your Retermination kit, you have this small piece of vulcanizing tape, and it has a piece of electrical tape on top of it. Just use this little bit of electrical tape to tape down the Kevlar at the bottom of the cone. After you have the Kevlar taped down, cut off any excess Kevlar behind the tape. Remove any Kevlar that you've cut away. This insulating paper, you can just tear that off even with the top of the cone. Unstrand all the wires. One pair of wires is twisted together with a plastic paper insulator on top of it. Remove this insulator. There'll be a small strand of Kevlar, and you want to cut all of this extra insulation and Kevlar with the top of the cone. The next step we're going to do is we're going to have to connect the inner and outer coax wires to our coaxial conductor for the cable.
A good quality yet affordable soldering station is very important. We use Weller brand, but others are available for between $150 and $200 that will work well. We typically use a 0.25mm soldering tip. We also recommend vice grips with pivoting heads that you can adjust them as needed throughout the retermination.
Okay, right now we have too much of this coax to work with. I'm going to cut this off so I have about 5 centimeters. Now you can't see it, but there is a clear plastic insulator that goes over the top of this braided copper. So about 5mm to 1 centimeter above the top of the cone, I'm going to just score that plastic insulator and remove the plastic.
Now that I have the plastic insulator removed, we're working with bare copper. So if I just take this small flat blade screwdriver, I can pick this copper apart. I'm using a screwdriver, but a dental pick is a great tool to keep around the shop for unbraiding these wires. I've picked apart the strands of this braided copper to where they're even with the stripped off portion of plastic insulator that I've done before. I'm going to twist these strands into two separate wires. I'm going to take one of these wires and cut it off. The remaining wire, I'm going to wrap around this white insulator until I have a good solid wrap around, and I'm going to cut the remainder off. The next step is I have to strip this insulator off to expose the center conductor of the coax. So I'm going to remove some of this excess and leave myself with about 15 millimeters to work with. Approximately 6 to 8 millimeters above where I've wrapped my outside conductor, I want to strip and expose my inside conductor. Remove any Kevlar that's on the inside of your conductor. Okay. Cut your inside conductor down to where you have about 1 millimeter exposed. Tin your center conductor. And tin your outside conductor. When you're tinning your outside conductor, you can't leave your soldering iron's heat on the conductor for too long, because there's a chance that you can melt this insulator for the inside conductor and fuse the outer and inner conductors. As you can see, I'm not leaving my soldering iron on the conductor for too long. Once you have solder all the way around your conductor, you're ready to proceed to the next step. Inside your retermination kit, you have a black and a red wire. Take your black and red wires and strip one end till you just have about 1 millimeter exposed. tin the exposed ends of your black and red wire. Your red wire is going to get soldered to the center conductor of your coaxial cable. Your black wire should get soldered to the outside conductor. Take care that both wires are facing vertically when you're done. It is important that you make these coaxial connections as small as possible so that everything fits back into the housing. The next step is to take this small black heat shrink that you get out of your retermination kit. The smaller of the two is going to go over your red wire. Use a heat gun, a hot air pencil, or you can use your soldering iron. Use half of the larger piece of heat shrink to cover both the red and the black wire. The next step is to put your thrust washer on. Your thrust washer goes towards the cone, and it has a flat side and a concave side. The concave side is going to go down towards the cone. The next step is to put your thrust ring on. Once again, like the washer, this goes over the top of all the wires and sits on top of the cone. The threads are going to go towards the drum end of the cable. Next, we're going to take our cable entry and push it up and pull to seat the cone inside the cable entry. Next, take your 19mm spanner wrench and your 15mm wrench and tighten the thrust ring into the cable entry. The next thing I'm going to do is lubricate all my O-rings and put all the O-rings together. So I'm using a little Molykote 111. This is what we use for non-moving O-rings. Seeing how
none of these O-rings have a moving seal or moving metal on them, Molykote 111 is perfect for this application. And once again, the two smaller O-ring tracks here are for the smaller O-rings. The larger O-ring track on our cable entry and our front connector holder are for the larger O-rings. The next thing I'm going to do is I'm going to use 1/2 of my connector holder to kind of gauge how much wire length I'm going to need. So I take my 1/2 connector holder and seat it into my cable entry how it would sit if the cable were assembled. And then I'm going to give myself about a 1 centimeter leeway on top of this 1/2 connector holder. I'm going to remove my 1/2 connector holder, and now I'm dealing with the appropriate wire length. Now that we're dealing with the appropriate wire length, the next step is to strip approximately 1 millimeter off the tip of all of these wires and then tin them. Now that I've got all of my wires stripped and tinned, I need to prep my socket insert for taking solder. I'm going to remove all the old wires from my socket insert and put new solder in. I'm going to use a little solder wick to take all the old solder out of our socket insert.
Be careful when you're soldering around the socket insert. It's made of plastic and you can melt it. Now that I've taken all the old solder out of my socket insert, I can now put some new solder in and put exactly how much I need. So I'm going to fill up the cups with this new solder. When you filled up your solder cups with all new solder, it should look something like this. The next thing we're going to do is we're going to align our socket holder to make sure that when we assemble our cable, the socket holder is going to be oriented in the correct direction. The front of our connector holder has several screw holes in it, and our socket holder has a hole to match each one of them. The socket holder only fits in here one way to where all the holes line up. So you have to line up all these holes and place the socket holder in, and then verify that you have the socket holder oriented in the correct position. Now, this cable is going to go together like this, so you want to remove the socket holder and then place it over the top of all your wires so you know the socket holder is going to be oriented the correct direction when it comes time to put it in. At this point, you want to refer to your wire pin location chart. Now that I've got my workbench set up to solder, you want to start by soldering the inside 4 connections and work your way to the outside. Pin number 1 is going to be located where this white line starts in the center of your socket insert. And this white line is going to spiral from pin 1 to 2 to 3 to 4 all the way around to 12. Next, I'm going to use my clear plastic heat shrink that's provided in the Retermination kit to heat shrink and insulate these wires as I solder them to the socket insert. Be careful not to touch the insulation on the wires when you're using a hot air gun or a soldering iron. You can melt them. I've got my inside 4 connections done. I'm going to shrink down all of my heat shrink before I move to the outside. When you're making your solder connections, You want to make sure that you have a good strong connection. These cables take quite a bit of abuse, so you don't want one of your solder joints breaking while it's mid-inspection. So every time that you make a solder connection, take the wire, pull on it, bend it around a little bit, make sure that it's not going to break off. After all the wires are connected, double check that you've soldered the correct wire color to the correct location. If you followed your wire color chart correctly, you should have all the wires soldered in the correct place with the exception of the brown wire. The brown wire uses the ground. Take your ground lug that you saved from your previous cable termination, remove the ground lug from the wire, and solder it onto your brown wire. Use the remaining black heat shrink from your cable retermination kit. The next thing that you want to do is take your socket holder, line up the inside alignment pin with the alignment tab of your socket holder, and then realign your socket holder so that all of the screw holes and the alignment pin line up with the cable end. The next step, we're going to take our ground screw and 1/2 connector holder. The ground screw goes through the ground lug, through the center of the 3 holes on the 1/2 connector holder, and finally through the center hole opposite the alignment pin of your front connector holder. Next thing you're going to do is take our Allen head screws along with our 2.5mm ball socket screwdriver and screw these into our front connector.
Next, align the 1/2 connector holder with your cable entry. And lock it into place. Use the shorter of your 2 countersunk screws to screw the 1/2 connector holder to the cable entry. Take the other half of your connector holder, snap it into place. Use the remaining of the short countersunk screws to screw the 1/2 connector holder in. Screw in the remaining 2 Allen head screws with your 2.5mm ball socket screwdriver.
Be careful not to pinch or damage any wires while putting in these last 2 screws. It's easy to do.
The next thing, I'm going to take an additional amount of Molykote 111 and re-lubricate these O-rings. Next step, I take my plug housing and line up the back 4 screws with the screw holes of my cable entry. Take the longer 4 countersunk screws and screw the plug housing to the cable entry. Now that we've got our cable reterminated with all the wires in the correct location, what we can do is now adjust our camera voltage. Using my camera voltage load test resistor, I've connected it to the end of my cable and I have my multimeter connected to my load test resistor so I can accurately determine what my voltage is. What you need to do is access your drum board. Here I have a KT180 drum, and up in the upper right hand portion I have a small microprocessor, a potentiometer, and a series of 4 dip switches. While the system is turned off, change dip switch number 1 to the on position. Next, turn your system on. When your system first turns on, it's normal for your camera voltage to spike much higher than what it normally is. So wait for the voltage to stabilize, and then as you can see, I'm reading 15.6 volts. With dip switch number 1 in the on position, it allows the system to change the camera voltage. With the potentiometer, adjust the potentiometer until your voltage is somewhere between 14 and 14.5 volts. Here I've adjusted my camera voltage to 14.45 volts. This is perfect. I'm going to turn my system off, turn dip switch number 1 and back to the off position, and I will have successfully adjusted my camera voltage. Now that we've checked our camera voltage and make sure that all of our connections are correct on our cable and our voltage isn't going to damage any equipment, you have to finish making the connector watertight. So what we need to do is take this PVC, push it up and inside the cable entry. This PVC tube should go inside the cable entry about a full centimeter. Next thing you're going to want to do is take some of this Perlon wire I've supplied with your retermination kit. Now we're going to make knots at several different places at the end of the connector that make the connector watertight. The knot is made by taking the end of your Perlon wire, take about 8 centimeters, fold it over, make a sharp bend, fold over both halves, and then start wrapping towards the bend in your Perlon wire. You want to make these wraps fairly tight, because like I said before, this is what gives the cable its watertight integrity. Once you get near the end, take your working end of your Perlon wire, thread it through the loop that we made at the end, and pull the shorter end of your wire until the knot that you've created is halfway between all your wraps. Then just cut off the excess. The wrap we've just created is going to keep any water that's going to go from the inside of this PVC into our connector. It's also going to hold the PVC tube in place. Next thing you're going to want to do is take your rubber boot and pull it all the way up and over your cable entry. Now we're going to make an additional Perlon wire wrap over the top of the cable entry, over the bottom of the boot, and just behind the boot. The first wrap here is going to be to prevent water from the outside of my cable from getting underneath my cable boot from the front side and into the interior of my cable. The back wrap is water from the outside of my PVC tube to get underneath the cable boot and into the interior of my cable. This third and final wrap back here is as an additional barrier to keep water from the inside of the PVC tube getting into the cable, and it also helps hold the PVC tube in place. We need to perform one more Perlon wire wrap at the very end of our PVC tube here. Supplied in the Retermination kit is this vulcanizing tape. The vulcanizing tape isn't sticky, but if you stretch it, it sticks to itself. The Perlon wire is used to keep water out of the cable. This vulcanizing tape is used to protect the Perlon wire. You want to peel the backing off of your vulcanizing tape and start wrapping over the top of the Perlon wire. I'm stretching my vulcanizing tape about 20% as I go. You want to wrap your vulcanizing tape approximately 2 inches past the Perlon wire. Now that I have my vulcanizing tape over all of my Perlon wire, I can now do the final step of taking on my 2 large pieces of heat shrink and shrinking them down over the top of my vulcanizing tape. And there you have it, a successfully reterminated mainline cable. I'm Josh Taylor, Master Service Technician with RapidView. Thank you for watching RapidView U.